Good morning again, everyone. We are starting the second part of the session 8 on technical solutions. And let's go straight to the point because we are delayed. The first presentation will be imparted by Clare Houlbrooke. Correct pronunciation, Clare? Very good. And the title is Initial Results from Managed Aquifer Recharge Trials in the Hekeo Hinds Plains, Canterbury, New Zealand. Clare, you have the floor.
All right, so I'm going to be speaking, giving some of the initial results from the Managed Aquifer Recharge trial that we have in the Hinds Plains area of Canterbury in New Zealand. Hopefully some of you saw my colleague's presentation from Bob Bauer yesterday morning, and mine fits in with his, and I'll show you how in a second. So in New Zealand, this is New Zealand, and Hinds Plains are in the South Island, part of the Canterbury Plains system. There are a mountain range through the middle of the South Island, and we're dealing with the alluvial plains on the eastern side. So Bob presented something similar to this yesterday. There's a timeline of progressively looking at managed aquifer recharge for this region over a number of years, and I'm just going to be presenting the two blue squares on this time frame. So looking at some of the three of the types of systems that we're looking at for this plains area, this catchment. And so I'm going to be, it's showing me again. Looking at basin called the Lagmore Basin, a large basin, and some other types of managed aquifer recharge that we're trying to do in this area. And leading on from this, we'll be moving towards the groundwater replenishment scheme that Bob was talking about in his talk. So the community, the Hinds catchment has degraded water quality in terms of nitrate. The nitrate levels are high due to agricultural intensification. There are also declining groundwater levels. This is what Bob showed yesterday. And the community has come up with a set of goals that they want to achieve with managed aquifer recharge. So those are to target and protect the drinking water supplies, enhance groundwater quality, improve base flows to the spring-fed streams on the coast, and improve the sustainability of the groundwater storage. So if we look briefly at the catchment and what we have the canal system that's been used for bringing in irrigation water supplies to either side of the Hinds River, which runs down the middle. We have the Rangitata and Ashburton rivers on either side of the plains, and we've had this long-established irrigation systems. We have currently, we have an ability to be able to use 500 litres per second for the trials, and we're utilising that because it's already been permitted and we have a consent available for it. The water is high quality. It's sourced through from the alpine areas of New Zealand, so high quality water. We have 18 testing sites at the moment of various designs. We are in the third year of a 5-year testing program, and it's being run through a governance group, which is the community-driven group that has overseeing the managed aquifer recharge trials and on into the groundwater replenishment scheme. So there's a lot of people involved and a lot of different companies and people from various different aspects in the community involved. So if we look a little bit more detail of what we're going to be looking at today, this is the catchment again. I'll be showing you some information about this, the basin trial, some of the smaller soakage systems that we're looking at implementing across the area, and up in the upper area of the Hinds River recharge system near the river. So if I talk first about the recharge basin, it's a pilot site. This has been established and infiltrating water since 2016. It gains its water from the irrigation system, so the canal delivers it to this pond. So this is an existing pond water travels through and is allowed into the managed aquifer recharge site through a control gate. The water then moves down through an existing water race system and then enters in through to the basin, which has a forebay and a main basin infiltration basin. And there's monitoring in there of levels and flow rates. If we look at a more recent photograph, we can see the effect of the forebay from the glacial flower type sediment that we get within the water, infiltrating water, and so that I'll see if this works. You might not see it, but so the forebay is certainly cloudier than the main basin, so that's what it's utilised for, reducing that sedimentation. So it runs at about 110 litres per second, and it has infiltrated 4.3 million cubic metres over the first 2 years of operation, and we're in the third year now. When we look at the lithology underneath the site, it's an alluvial sequence, and there are a lot of variations in that lithology from the gravelly sands down through to more silty deposits, and it's highly variable. And what we find is that these silt and clay layers restricting the flow of groundwater down through from our basin. So in a schematic of what's happening underneath the site, as we've been infiltrating that basin, the water's been moving along and then it starts to move out along that perched layer up above. It is making its way down through to the regional system, but it's being held up and then making its way down sometimes in some of these monitoring bores along the edge of the bore, the outside of the bore. And I think that's and if you take note of the bore in the middle there, GWD4, which is about 1 kilometre from the site, I'm going to show you some data on that in a second. So the trial site is located here within the catchment, and if we look at what that plume looks like from a water quality changes, and we're focusing at the moment on nitrate because that's our water quality of concern is the nitrate concentration. So if we've noticed that in the first year we had the plume extend about 3 kilometres, and then out to year 2 we've observed water quality changes out to about 7 kilometres from the site. And in year 3 we're preparing for extending our monitoring outwards and down towards the spring-fed streams, which are now within that zone. The red bores are bores that are outside of the plume and are increasing in nitrate concentration or are stable, and the green ones, we've seen a decrease in nitrate concentrations. So if this is the bore GWD4, which was in the middle of the schematic I showed, groundwater levels are shown in dark blue, and those levels from the start, I'll just show you that year 1 started here, and from the start of that operation, the groundwater levels actually responded by about 18 metres and quite quickly. So 18 metres rise in groundwater level, and then progressed through, and it is very sensitive to fluctuations in recharge rate from the basin. At the same time, the nitrate concentrations have dropped from approximately 7 grams per cubic metre down to, well, at the end of the second year, about 2 grams per cubic metre. And taking into account that the community is trying to achieve an average of about 6.9 for the region, but there are many bores that are a higher concentration than this. I'll just show you the next one. So we've also, the nitrate concentration is shown in samples from the laboratory in the purple dots, but we also have a real-time nitrate sensor, and that is shown with the green line. So that's from our colleagues at Lincoln Agritech in New Zealand who designed a nitrate sensor for us. It gives us a little bit more detail on how that system is responding, but those concentrations have maintained over the period of time, the 2 years that we've been operating. So this is really I just wanted to show you, there's a lot of different bores on here, really I just wanted to show that wells out. This is in nitrate nitrogen concentrations, and we see that concentrations are fairly high and stable outside of the plume. This is nitrate nitrogen, so the drinking water standard is 11.3, so this is over drinking water standard. And so outside of that plume, we're not seeing any change, and we're seeing some wells that are actually increasing. And within the plume area, we're seeing decreases in the nitrogen concentrations, especially early on, and then as the plume has extended out, we've seen changes in other bores as it's extended through. And in year 2, we've seen some new bores and decreases in concentration in those as we've gone. The effect of the lower permeability layer and that perching was thought to be restricting the amount of flow that we're getting out of the basin. So we have been looking at ways to increase the flow out of the basin, and a part of that was drilling last year of a soakage hole. So this has been backfilled with coarse gravels and cobbles, and it has a piezometer within it, and what we're trying to achieve with that was to increase the flow from the basin beyond that perched layer. We've been testing it, and we've been altering the level within the basin where it might be that the alterations that we've done of the levels in the pond might have been more effective in the end, more effective than this system, but it was worth trying. So I'm just going on now to the soakage sites. So these are the smaller systems that are being implemented on individual farms. So there are small soakage system. This is two of the ones that have been installed. There's 16 altogether. So we've got a variety of ponds and open channels as our supplies for water for these soakage systems. The design is approximately 6 metres deep with backfilled cobbles. We've been infiltrating water into them. 15 to 30 litres per second is the estimated long-term rate of recharge into these, some of these sites. We're progressively ongoing with testing them, and it hasn't finished yet. When these were tested, it was during a period of high rainfall and high groundwater levels. So we're expecting that during periods when the groundwater levels are lower, that we will get higher infiltration rates, that it was the period of time that we were first doing this testing. So then I'm just going to touch briefly on the river recharge project that we've got in the upper catchment. This is beside the Hines River, the south branch of it. This river has, again, high nitrate concentrations, poor water quality. It has lower flows, some degraded habitats. So we've been working very closely here with the community to re-establish wetlands, eel habitats, riparian vegetations. We have 2 recharge areas. We have the water coming in again from the Rangitata race, the big canal at the top of the catchment, and it is siphoned in through and into recharge area 1. Then there is a diversion around the wetland, and then we have a second recharge area. And I'll just show in map form. So we're delivering at the moment 100 to 170 litres per second. Mm-hmm. The intention is for this water to recharge into these areas and support the wetland, make its way down into the groundwater system, help out with high nitrate levels again in the local groundwater, and also help with the river flows and quality. There is a series of monitoring wells and flows up and down from the site, and also ecological surveying. So it's the first year of operation at the moment. We do have, it's only just been operating in the last few months, and we've had some concerns about levels of sediment and turbidity in the water, and I'll show you that in a second, and how we're trying to work through that is careful management of the flows to make sure that we're not causing any issues with sediment. And so this is a month ago in April, upstream and downstream of the site, and there is potentially some turbidity coming through that we've been monitoring and looking at ways to manage that. So in conclusion, this is a slide that Bob showed yesterday about the progress that we've got within this catchment, and I've just been talking about some of these techniques that we're looking at. They're going to be moving through, and those learnings that we get from these different techniques will be helping to build how we will carry that on through into a groundwater replenishment scheme for the whole catchment and the whole plains that Bob described yesterday. That's it. Thank you.
Thank you very much, Claire, for your kind introduction. Any question for Claire? Yes, please.
Hi, thanks very much for your talk. That was very interesting. I'm Ben Hall from Australia. Would you mind just talking a little bit more about the design of the soak wells, the deeper ones that were trying to get past that perching layer, diameters and lining on those sorts of things?
So it's a 1.2 diameter down to 18 metres deep. It has casing through to 8 metres deep, backfilled with coarse cobbles. It probably wasn't quite deep enough. I think it probably could have been a bit deeper. We were restricted with what we could do.
Any other question?
Yes, thank you, Claire, for an interesting presentation. I was wondering, you mentioned nitrate as your main concern. You're infiltrating high-quality surface water with no nitrate in an aquifer that is already contaminated with nitrate, right?
Correct.
So is it just the dilution, or is there any nitrate removal going on in the aquifer?
We think that it is dilution. There are a lot of techniques being looked at within New Zealand at how to look at nitrate removal from the point of view of putting in sort of carbon barriers and other types of systems, because although I'm talking about this from a ISMAR point of view, this is only one of the tools that they're looking at. They're actually having to do a lot of restrictions on their farms to reduce the amount of nitrate that they've got coming out. So this is only a small part. They actually have to reduce their nitrate output by 36%. So yeah, so that's sort of another section that they're looking at for denitrification.
Yeah, hi, thanks for the presentation. So one question I have, is this recharge system a perennial system? Like, is it happening throughout the year, or there are specific periods like high rainfall events or monsoons, not rainy season, I would say? Or when you plan to upscale it, like having more sites, as you said, like 18 more sites, something like that?
Oh, so there are currently 18. Including all the little ones, and the river site and the big basin. And there will be an expansion. That was what Bob spoke to in his presentation of yesterday. I'm sorry if you missed that one, but it's expansion right through to cover the whole the region. Your initial question, sorry.
Is it a perennial year-round system?
When the water is available, at the moment we have this water that's available through the water permit system that's extra from the irrigation scheme. Mm-hmm. And so it is most of the year, but we're having to turn off and on due to either no water being available from the river restrictions, or we also have restrictions based on the amount of rainfall and other consent conditions. So we are having to turn off and on, and there are some periods where it is off. So.
Okay, thank you very much, Claire.